So the last part of chapter 4 is a thing called percent composition. You guys are really comfortable with percent. If you get a 45 in a test and the test is worth 46, you are not going to tell your parents you just got a 45. You're going to convert that to a percentage, right? You're going to take your score, the part, divided by the whole, 45 times 46, and multiply it by 100 before you tell your parents that score. So that's what percent composition is. And it works for chemicals as well as test scores. Now, simple calculation. If we have 30 people in the classroom and 24 of them have brown eyes and 6 have blue eyes, and I want the percentage of people with brown eyes, I take the part, the number of people with brown eyes, I divide by the whole, the number of people in the classroom, I multiply by 100, and I get 80%. Okay, have to start out with the easy one. So, to look at percent composition in chemistry, the percent composition by mass of each element in a compound is its oh God, that was bad. Try this again. Percent composition is the percent by mass of each element in a compound. So, how do we do this? So suppose I want to find the percent by mass of each element in sodium chloride. That says NaCl, for those of you who can't read my handwriting, which is most of you. So the first thing I want to do is I want to find the molar mass of sodium and chlorine. Now for these molar masses, I am going to one place past the decimal. That's because I know these molar masses. So if I look up sodium, it's 23.0 grams in 1 mole, and chlorine is 35.5 grams in 1 mole. So you're going to find the molar mass from the periodic table. Now I need to find the molar mass of the compound. There's 1 sodium and 1 chlorine, so all I have to do is add 23 to 35.5, and I get 58.5 grams per mole. That's for NaCl. Okay, so these are my parts, 23 and 35.5. This is my whole, 58.5. So what I'm going to do is divide each element's mass by the molar mass of the compound. So to find the percent of sodium, I'm going to take 23 grams divided by 58.5 grams times 100. Okay, that would be unitless, right? For percentages, the units always have to cancel. So doing that little bit of math there, I have 39.3% sodium. Now, how can you find the percent of chlorine? There's a couple of different ways. One of them is better than the other. Since there are only 2 elements, you could take 39.3% or 39.3, oops, this should be percentage, yeah it is. You could take 39.3% and subtract it from 100%. But what if you made a mistake? What if you were in a hurry on a test and you happen to write down 33.9? Okay, just transpose these last 2 numbers here, mix them up. Then when you subtracted that from 100, you would not get the proper percentage for chlorine. So it's always best to actually calculate the percent by mass of each element in a compound. So here we're going to take the 35.5 grams, the amount of chlorine we have in that sample, divide by 58.5, multiply by 100. That gives me 60.7% of chlorine. Now, if I add those up, that comes out to be 100.0%, which is a really, really good way to check your answer. Now, depending on the sig figs you use, how you do your molar masses, if you have something between, say 99.5% and 100.5%, you are probably good. You want it to be in that range, though. It doesn't have to be exactly 100.0, but it should be very close to 100. So just keep that in mind. Okay, now let's use percent composition to do something else. So we are going back to the sodium chloride. All right, because we already know the percent of sodium and the percent of chlorine. It says, how many grams of sodium are, AR, can't spell, are in 15 grams of sodium chloride. So the first thing you want to do is take the percent of sodium and write it as a decimal. So 39.3% that we got from the previous problem would be 0.393. Okay, we always do that when we're doing a problem like this because we're going to be multiplying by this number. And if you multiply by 39.3, you'd end up with just an enormous amount of sodium. So then you're going to multiply the fraction you have by the total mass of sodium chloride. So the total mass of sodium chloride is here. It's 15.0 grams. I'm going to multiply by 0.393, which is the fraction, which is chlorine. And when I multiply that together, I have 5.90 grams of chlorine in the, is that what I was looking for? I was looking for sodium, sorry. Percent sodium. Okay, so let's do one more. Let's find the percent of carbon in CH4. So the molar mass of carbon, and I'm just using 1 sig fig or 2. I'm going to assume carbon weighs 12 grams instead of 12.01 just because it's easier. There are 4 hydrogens, so the mass of hydrogen in CH4 is 4 grams. So 12 plus 4 is 16 grams. The percent hydrogen isn't just the amount of 1 mole of hydrogen, it's 4, because I have 4 grams of hydrogen in the sample. So 4 grams of hydrogen in 16 grams of CH4 times 100. And for the percent carbon, I have 12 grams of carbon divided by 16 grams of CH4 times 100. 4 divided by 16 times 100 gives me 25% hydrogen. 12 divided by 16 times 100 gives me 75% carbon. And that does add up to 100%. Okay, so remember, if you have more than 1 atom of something in a compound, or more than 1 atom of a particular element in a compound, that you have to use the total mass of that element when you are finding the percent composition. You'd never use 1 gram of hydrogen over 16 grams, okay? Because that's not what you have. You've got 4. That's it for percent composition. It's a pretty easy topic.